Hello everyone. Today I'll be discussing the solutions of GATE 2022 Aerospace Aptitude paper. So let's begin. Here's the first question. Which one of the following is a representation of all the values of x that satisfy this inequality on the real number line? So it's a straightforward question. Just rearrange the given expression and put it on and select the appropriate diagram. So let's start. We have 2 minus 5x is less than or equal to minus of 6x minus 5 all divided by 3. So multiplying both sides by 3, I'll be getting 6 minus 15x is less than or equal to this minus I'll multiply over here, which will and write it in reverse. So 5 minus 6x, getting this here, 6 minus 5 will give me 1, which is less than or equal to 15x minus 6x. That is 1 is less than or equal to 9x, or x is greater than or equal to 1 over 9. So since this is positive, so the dot will be on the right hand side of 0 and x is greater than that. So this option C is the correct option. Okay, if it was x less than, it would have been option A, and if it had been negative, maybe option B. Moving on to the next question. If f of x is 2 ln root of e raised to x, what is the area bounded by f of x in the interval 0 to 2 on the x-axis? So first simplify f of x. F of x is equal to 2 ln of square root, I'll write it as raised to 1 over 2. This 1 over 2 I'll take outside, and 2 into 1 over 2. Then ln of e raised to x will just be x. Okay, so f of x is simply x. And the required answer, it is the area bounded. So let me call that A. It's bounded between 0 to 2. So integral 0 to 2 f of x dx. So this will come to integral 0 to 2 x dx, which is x square by 2 from 0 to 2, which comes to 2 square by 2, which is 2. So option C is the right one. Next question. A person was born on the 5th Monday of February in a particular year. Which one of the following statements is correct based on the above information? And the 4 options are there. The 2nd February of that year is a Tuesday, 5 Sundays in that month of February in that year. 1st February of that year is a Sunday, and something else. Let's just find out what's special about this. They're asking for a very specific case. So it's saying 5th Monday of February. See, when we take February, it can either have 28 days or 29 days. Right? For leap year, it is 29. When it is 28 days, we can write it as 7 into 4. And 29 will be 7 into 4 plus 1. This 7 is the number of days in a week. No, week, this is 7. So it can arrange itself, I'd say, neatly. If I say Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, If it starts with 1 here, 1, 2, 3, 4, 5, 6, 7, then 8 will come, here 14, here 21 will come, and 28. Okay, I can maybe shuffle this again, maybe start with Tuesday also, if it was 28. The point is that only 4 weeks. So if you pick any day, we can only have 4 of those in 1 month. But the thing is, it says 5th Monday of February. So let me just erase this. Hold on, I don't need to. 1, 8, 15, 22, then 28. If it was 28, then I'd be done here, which will not satisfy this 5th Monday thing. For 5th Monday, 29 has to come. So what I've done here is get the exact way the month of February is happening in that year. So we can fill this up, 3, 4, 5, 7, and the rest also. Just the structure is needed. Now we just verify the options. The 2nd February of that year is a Tuesday. So 2nd February, it's right here. It is a Tuesday. So this is correct. There will be 5 Sundays in the month of February in that month. This was Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. This is Sunday. These are only 4. So this was wrong. The 1st February of that year is a Sunday. 1st February was Monday. So again wrong. All Mondays of February in that year have even dates. So all Mondays, 1, 8, 15, 22, 29, there's odd. This is odd, this is odd, and this is odd. These two are even. So this is also wrong. Option A is the correct one. Moving on to the next question. Which one of the groups given below can be assembled to get the shape that is shown above? Using each piece only once without overlapping. Rotation and translation, they can be used. So let me just draw this once. Hold on. Yeah. This is the given shape. I can divide this in this way and this way also. And this will satisfy option B here. Okay. What else I can do is, let me select this. Is this the right one? No. This one too. 1, 2, 3, 4. So option C also, I can get it by cutting the given piece. Options A and D. In D we have this big triangle. It won't be matching here. And also in A, we have one less piece compared to B. So this also won't happen. These two are pretty much the same, option A and D, with just this triangle being a little more pointy. So this is also not right. So options B and C are the correct ones. Next question. For the past 10 days, the average daily production of a company was 100 units per day. And if today's production was of 180 units, it changes the average to 110 units. What is the value of M? So the past average, how much was it? 100. So past total is 100 M. Okay. This is 100 units per day. So this will be units. Then today's production of 180 units. So to this 100 M units, I have to add 180. It changes the average to 110 units. So this is the total number of units, 100 M plus 180. Total number of days is M plus 1. And it gives the average as 110. So we just have to solve for M. What is the value of M? So 100 M plus 180, it gives 110 M plus 110. Rearranging, I'll get, let me see, 180 minus 110 is 70, is 10 M, or M is equal to 7, which is option C. Moving on to the next question. Consider the following functions for non-zero positive integers p and q. F of p comma q is p raised to q. G of p comma q is p raised up to q terms. So which one of the following options is correct based on the above? Let me just write it. F of p comma q is p raised to q. G of p comma q. Let me just write this as p with an arrow q. Okay, for convenience. Let's start verifying the options. Option A, if I see it, f of 2 comma 2 equals g of 2 comma 2. So f of 2 comma 2 means 2 raised to 2. Which will be 4. This is the LHS. RHS is g of 2 comma 2. Let me clearly write this. Then g of 2 comma 2. This is going to be 2 raised to 2 raised to 2 raised to 2 and so on. This has to be 2 times. So this is 4. This is correct. Then we have option B, f of g of 2 comma 2. Write that. F of g of 2 comma 2 is 4. 4 comma 2 is less than f of 2 comma g of 2 comma 2, which I've already calculated as 4. So this LHS is 4 raised to 2, RHS is 2 raised to 4. Both sides are 16. So this is not correct. Clearly they are equal. Next we have g of 2 comma 1. Let me write it here. G of 2 comma 1 is 2 raised to 2 raised to 2. This has to be 1 time, which is 2. This is g of 2 comma 1. Then f of 2 comma 1. This is 2 raised to 1, which is 2. So these two are equal though, and it says it's not. So this is wrong. Option D. F of 3 comma 2. This is 3 raised to 2, which is 9. Then g of 3 comma 2. This is 3 raised to 3 raised to 3 raised to 3, so on, 2 times, which is 27. So clearly this is bigger, g of 3 comma 2. Option is the reverse. So this is again wrong. Only option A is correct. Next question. 4 cities P, Q, R and S are connected through one-way routes as shown in the figure. The travel time between any two connected cities is 1 hour. The E is 1 hour. The boxes beside each city describe the starting time of first train of the day and their frequency of operation. So for example, from city P, the first train of the day starts at 8 a.m. with frequency of 90 minutes of each R and S. Person does not spend additional time at any city other than the waiting time. So if a person starts from R at 7 a.m. and is required to visit S and return to R, what is the minimum required time? So a certain pathway is given and a route is also given. We start from R, destination is S, and then back to R. We have to take the shortest path. So let's find all the possible paths first. Starting from S, I will go to, cannot go to P, I cannot go to S also directly. I have to go to Q. And from Q, I cannot go to R or cannot go to S also. The arrows are going towards Q. Only the outward arrows I can follow. So next one is P. Then from P, I can reach S. And from S, I can reach R. So the given graph, it is very restrictive. We are not free to travel to cities as our wish. And this is the path that they want us to follow. So for this path, what is the shortest time possible? That we have to find out. Before we do that, let's prepare ourselves a little bit. What are the times? Trend, we are seeing the trains itself, the train timings. What are the possible train timings? We should see. So for, let me start with R. 7 a.m. Then the next train is after 1 hour, 60 minutes. So 8 a.m., 9 a.m., 10 a.m. and so on. For Q, it is 120 minutes waiting time. I'll just write 5 a.m., then 7, then 9 a.m., then 11 a.m., then 1 p.m. and it goes on. Then for P, I'll write starting from 8 a.m., then 90 minutes, so 9:30 a.m., then 9:30 plus another 90 minutes will give me 11, then 12:30 p.m. and so on. So P, Q, R, finally S is remaining. This has the shortest waiting time, 45 minutes. So 8 a.m., then 8:45, 9:30, 10:15 and so on. The whole point of writing so much was to get a feel of this. So now we start traveling. I start from R at 7 a.m. Then start from R. This is at 7 a.m. Then I have to go to Q. So from R, I'll be going to Q. Since the commute takes 1 hour between any two cities, I'll be reaching at 8 a.m. and I'll be leaving at, since I reach at 8 a.m., it's between 7 a.m. and 9 a.m. I'll be leaving at 9 a.m. Fine. This is for reaching, this is for leaving. Then after this, I'll be going to P, left at 9, so I'll be reaching at 10 a.m. Then I'll leave at, if I reach at 10 a.m., I'll have missed the 9:31, reached at 10, I'll be leaving at 11 a.m. Then from P, I'll be going to S. I'll be reaching, since I've left at 11 a.m., reaching at 12 p.m. because 1 hour commute. Let me just mention that 1 hour, 1 hour, 1 hour here. Then I'll be leaving at, okay, I'll have to write a few more over here. 10:15 and adding another 45, I'll be getting 11, 11:45 and 12:30. Fine. So it's 12:30 p.m. I'll leave and finally reach R after 1 hour at 1:30 p.m. So 7 a.m. to 1:30 p.m. that is 6.5 hours. So option A is the correct one. It's a lengthy question, specifically because of this S thing. It has a lot of entries. But if we understand it and write it clearly once like this, it will make sense. Next question. This is the final question. So equal size circular regions are shaded in a square sheet of paper of 1 centimeter side length. Two cases, case M and case N, are considered as shown in the figures. So in case M, 4 circles are shaded, and in case N, 9 circles as shown. Ratio of areas of unshaded regions in case M and case N. So let me take case M. So 4 circles are there. Let me take the radius of each circle. Radius will be, if I take this this entire length is given as 1 centimeter. So, and this will be the radius. So it's 0.25 centimeter radius. So total circle area will be there are 4 circles and pi r square, pi into 0.25 the whole square, and unshaded is one minus this quantity. This one has come as the area of each 1 centimeter square sheet. Since side is 1 centimeter, area will be again 1. So 1 minus 4 pi 0.25, I'll write it as 1 by 4 the whole square. This comes to 1 minus pi by 4. Fine. Now case N, we'll just follow the same thing. 9 circles. Radius will be, there are 3 diameters which make up 1 centimeter. So 6 radius, 6, let me write that once properly. 3 diameters, they'll give 1 centimeter length over here. This length 1 centimeter, it has 3 diameters. So there are 6 radius, it is 1, or the radius is 1 by 6. So net circle area, it will be 9 into pi into this radius square by 6 the whole square, which is let me see, 9 pi into 1 by 6 into 1 by 6. 3 3s are 2. This also gets cancelled. So this comes to again pi by 4. Finally, unshaded over here is 1 minus pi by 4 again. So the unshaded area in both cases is 1 minus pi by 4. See? So the required ratio is 1:1. Option B is the correct one. Since both the unshaded areas, they are the same, the ratio is 1:1. So, well, intuition, it says that it gives a feel that in case of the larger number of circles, the unshaded area is lesser. There are more circles, but it's really not the case. You can actually extend this to even higher cases if, let's say, 16 circles or maybe 25 circles also, or even higher up, the unshaded area, it will remain the same. That one observation we can make here. So that's it from me, guys. Thank you for your time.